Hi, 5th grade. Today we're going to be doing Module 3, Lesson 9, and today we're going to start learning how to add fractions numerically. So that means we're going to start moving away from these pictures, and we're going to start using just numbers to help us solve these addition problems. So please make sure you have your Lesson 9 notes out, and let's go ahead and get started. So normally when we have been adding a half plus a fifth, what we would show is a model showing a half shaded in and another model showing a fifth shaded in. If I wanted to make these models have a common denominator, I know that this half would need to be split into fifths. And what I am doing here is I want you to take a look at this problem that I have. And you may remember this way back from Lesson 1. And in Lesson 1, we made equivalent fractions using a multiplication problem that looks something like this. And we know that whenever I'm splitting up my model, what I'm also doing is creating equivalent fractions. So this part right here, this math right here, and me cutting this into fifths is basically the same exact step. It's just that I'm using math to create that equivalent fraction instead of using a model to create my equivalent fraction. So I want you to notice what I did right here. I took this half and I split it into groups of 5. Because remember, we can think of that multiplication symbol as groups of. So this one group, this one part that was shaded in, this one part got shaded into groups of 5 instead now. So I have 1, 2, 3, 4, 5. And what I did is I took one group of 5, and then what I also did is I took whatever I do to the top, I also have to do to the bottom. So I also took these two groups, because remember we started off with a half, and I had two groups, and these two groups are also getting split into groups of 5. And what that lets me see is that I have one group of 5, and then two groups of 5 in total, which then gives me my new fraction of 5/10, because 1 times 5 is 5, and 2 times 5 is 10. And if I take a look at my model, I also see this, because I have 1, 2, 3, 4, 5 out of 10 in total. So what we're going to start moving away from is just using the models, and now just using the math to help us solve these problems. And when I move over here now, I see that I have a 1/5, and I know that this 1/5, since this model was split in half, then this model needs to be split in half as well. But what I just did is I just created groups of 2 in this model, or for this fraction. And by creating groups of 2, I'm now doing 1 times 2, which gives me 2, and 5 times 2, which gives me 10. And now I can add my fractions together. So I get 5/10 plus 2/10, which gives me 7/10, and that would be my final answer. And what you may notice is that the number I'm multiplying over here is the same on the top and bottom, but it's also the number that you see on the other side of the problem. So since there's a 2 here, I'm multiplying by the 5 over here. On this side, I started with the 5, but then I multiplied it by the 2. And this will make more sense later once we do a couple more examples. So this is our first type of problem, and now we're going to move into another one. So please make sure you have all of those notes written down. And for this one, we're now going to be doing a half plus 2/3, except this time I'm not going to use any models to help me out with this one. What I am going to do though is I'm going to rewrite this problem with some parentheses. So you're going to rewrite it looking like this, and then what you're going to do is you're going to write this fraction right here, 1/2, except you're going to create that line a little bit longer, and then this 2/3, you're going to write that over here like this. Now, we're also going to put in multiplication symbols. So again, kind of a throwback to Lesson 1. And we are now going to multiply so that we have common denominators. So I have 1/2, and I'm trying to make it equivalent to whatever 2/3 is going to become. So what I'm going to do is I'm going to take a look at this other denominator, and I see that that is a 3. So what I'm going to do is I'm going to also multiply this by 3. And then on this side, I see that I have 2/3. And that the other denominator is a 2. So I'm going to multiply this by 2. And then I'm going to complete my multiplication problems on both sides and write my new fractions and see if they are equivalent and that they have that common denominator, and then add them together. So we have 1 times 3, which gives me 3. 2 times 3, which gives me 6. So 1/2 and 3/6 are equivalent. And then I'm going to add 2 times 2, which gives me 4. And then 3 times 2, which gives me 6. So 2/3 and 4/6 are equivalent to each other, and this is also a common denominator. So, and this is 4/6. So now we can add these together. So I have 3/6 plus 4/6, which gives me 7/6. And then when I want to, I take a look at this fraction and I see that this is an improper fraction. So I need to change this into a proper fraction. And to do that, remember we create that addition problem. So I know my denominator is going to be 6, just like it is here. I need to create a whole number, so I create 6/6 plus the remainder, which would be 1/6, so that I can get to 7. 6 plus 1 equals 7. The 6/6 becomes 1 whole, and the 1/6 gets attached to that. So my final answer for this problem is 1 and 1/6. But you will notice that I just kind of multiplied by the opposite number in the denominator for each section. All right, now we're going to move into a tougher problem now. And for this problem, we're going to have some bigger fractions. We have 5/9 plus 5/6. Now, in this situation, by now you probably think, okay, I have 5/9. Over here, I have 5/6 over here. And again, I'm just going to multiply by whatever number is on the other side. So you would put a 6 over here, since the 6 is opposite of this 9. And then on this side, you would put a 9. And you could do this, but my answers would be way too big, and it would be kind of hard for me to eventually simplify this answer. So yes, normally when we are looking at these addition problems, we can normally just multiply by whatever number is on the other side, but there is actually an easier way to do this. And what that is you'll notice on your sheet you have something that says LCM. And the LCM is the lowest common multiple. And what I mean by this is we are trying to find a number that both of these fractions can have as their denominator that would give them a common denominator, but the number is going to be a lot smaller and easier for me to work with. So instead of having 54 as my denominator, like I would have if I did 9 times 6, I'll have a smaller number that will make it easier for me to eventually simplify. So what I'm going to do is I'm going to have the number 9, and then I'm going to have the number 6, and I'm going to figure out their multiples, and then what is their smallest multiple. So work along with me so we can figure out how this works. So what I'm going to do is I'm going to count by 9. So we need to skip count by 9s right now. So I do 9 times 1 in my head, which is 9. 9 times 2 is 18. And then I'll do 9 times 3, which is 27. I'm going to stop right there. I don't want to do all of my 9s. I'm just going to do a few and then see if 6 has any common multiples in there. So I do 6 times 1 in my head, which is 6. 6 times 2 is 12. Nothing matching yet. Then I do 6 times 3, and that gives me 18. Now I'm going to stop right here because this 18 is my lowest common multiple. This is the smallest number that matches in both rows. So what I need to do now is I need to think a little bit, and I have to think about, well, in this problem right here, 9 times what is going to give me 18? Well, I know I could do 9 times 2, and that would give me 18. And remember, whatever I do to the bottom or the top, I have to do to the other side. So I'm also going to multiply the top by 2 as well. Then over here, I have 5/6, and I have to multiply that and make this also 18. So I think about, well, 6 times what will give me 18 in my denominator? Well, I could do 6 times 3, and that would give me 18 in my denominator, and whatever I did to the bottom, I also have to do to the top. And now I can finish multiplying. So I'm going to do 5 times 2. That gives me a numerator of 10, and then 9 times 2, which gives me 18. We do 5 times 3, which is 15, and 6 times 3, which is 18. And another reason why we like to do these multiplication problems and start moving away from those models is that if you were to create a model for 5 9 plus 5 6, you would have 54 boxes that you would need to count and show. But if we do our multiplication like this instead, in our addition like this instead, we're able to find this least common multiple and then add up numbers that are a lot easier for us instead of having, again, to show those 54 boxes. So that's why we like doing it this way instead. So now we're going to be adding 10 18ths plus 15 18ths. So we're going to add 10 plus 15. That gives me 25 18ths, because remember my denominator is not going to change. So I have 25 18ths, and this is an improper fraction because my numerator is larger than my denominator. So we're going to write that addition problem to help us create that equivalent, or that proper fraction. So since I have 18 right here, I need to create a whole number, so I'm just going to put that same number up on top, so I have 18 18ths. And then I need to add the remainder to get to 25. So 18, let's see, we can even do a standard algorithm to help us out with this. We have 25 minus 18, so we can make that a 15, make this a 1. 15 minus 8 will give me a 7, so I now need 7 18ths left over. 18 18ths becomes 1, and then 7 18ths will get attached to that. So my final answer for this problem would be 1 and 7 18ths. And again, this is way easier than if I just kept the 9, if I just did 5 times 6 over 9 times 6 plus 5 times 9 over 6 times 9. Because what I would have gotten is 30 54ths plus 45 54ths. I would then have to add all of this up, which would give me 75 54ths, and then you would need to change this into a mixed number and then also simplify that. So by using the LCM, we skip this really hard step right here, and we just make it a little bit easier for ourselves. So let's go ahead and erase this, and we're going to move on to our last problem together, which is on the back. And we are now, this is going to look tricky, but I promise it's not that bad. So we have 2/3 plus 1/4 plus 1/2. So what we're going to do for this problem is that we are again going to think about what our least common multiple is, because I can't just swap the numbers and multiply them all by each other. But I am going to create this again. And this is pretty much how all your problems are going to start. So if you don't know how to start a problem, write out your problem just like this, and then start thinking what you can multiply each number by. And then we'll have a half. So this is what our problem is going to start out looking like. And now I need to figure out what I need to multiply each of these by so that they all have the same denominator. Because remember, I can't add these yet until they all look the same. So what I'm going to do is, again, I am going to find the LCM of all these numbers, the least common multiple. So I'll look at my 2's, my 3's, and my 4. So I'm going to count by 2's. So I have 2, 4, 6, 8, 10, 12. And I'm going to stop right there. Then I have my 3's. I have 3, 6, 9, 12, and then I'm going to count by my 4's, and you may even see where I'm going with this. So I have 4, 8, and 12. So when I am looking for the least common multiple between all three of these numbers, I want to find the smallest number that matches in all three of these rows. So even though the 2 and the 3 have the 6 right here that match, my 4 row does not have any 6s, so I can't actually use that number. What I can use, though, is this 12, because all three of these rows have a 12, and it's the smallest number in each of these rows. So what I need to think about now is I need to think about, well, what am I going to multiply each of these fractions by so that they all get a denominator of 12. So to do that, I'm going to start off with my 2/3, and I'm going to take a look at my denominator, and I'm going to think 3 times what is going to give me 12. I know that 3 times 4 will give me 12, so I'm going to put a 4 here in my denominator, and remember, whatever I do to the bottom, I also need to do to the top. Over here, I have 4 times what is going to give me 12? Well, I know that 4 times 3 will give me 12, and since I did this to the bottom, I also had to do that to the top. And finally, over here, I have 2 times what? It will give me 12, and I know that 2 times 6 will give me 12. And then since I put that in the bottom, I also have to put that on the top. And now I can multiply and then add these up. And again, this process is a lot easier because if I were to use models for this, it would be really difficult because I can't do 3 models all at once, adding them together. I could try, but it really wouldn't work. So doing the math makes this problem a lot easier for us to do. So we're going to start with this fraction over here. We have 2 times 4, which gives me 8. 3 times 4, which gives me 12. So I have 8/12. I have 1 times 3, which is 3, and 4 times 3, which is 12. And then we have 1 times 6, and 2 times 6, which is also 12. So now that all three of these all have the same denominator, now I can add them up. So we took our starting fractions, found the LCM, created equivalent fractions, and now we can add since they all have the same number in the bottom. So I'm going to take this part by part. So I have 8 plus 3. 8 plus 3 gives me 11, and then 11 plus 6 gives me 17, and remember my denominator stays the same. So I have 17/12, but remember I don't like improper fractions like that, so I'm going to change it. I'm going to use that addition problem to help me out with this. My denominator is going to stay 12. Then I'm going to think about how can I create a whole number. I'm going to do that by putting that same number up on top. So I have 12/12 plus. I have to think about 12 plus what is going to give me 17. Well, 12 plus 5 gives me 17, or 17 minus 12 is 5. 12/12 becomes 1 whole, and then 5/12 will get attached to that, and that is my final answer. So 5th grade, when you move on to the you try problem, you're going to have another one of those tricky ones where you have to find the LCM. So I'm going to show you how to get started on that step, and then you'll be responsible for solving the rest of the problem. So you're going to be solving for 4, 6 plus 2 4ths. And for this problem, I have the 6 and the 4 here, and I'm going to find the lowest common multiple, or the LCM, of 6 and 4. So I'm going to start by showing you a couple multiples of 6, and I'll show you some multiples of 4. And then you are going to be responsible for finding the least common multiple. Even though there's multiple numbers that look the same, you are trying to find the smallest number that both of these rows have in common. And then when you go to set up your problem, it should look something like this. It should look something like this. And then you need to plug in the numbers here that will give you that least common multiple as your denominator, and then solve from there. If you need any help, of course, please raise your hand, and I'll be coming around to help you out. And good luck today, and great job, 5th grades.